In this video, we're going to work on the ALEKS problem called graphing an exponential function and its asymptote f of x equals a e to the x minus b plus c. This problem is giving us a function to graph, and it's actually quite a bit easier than it seems like it might be. The one thing I want to point out to you is that ALEKS wants this graphed in a particular way. So first of all, it wants you to plot 2 points on the graph, and then it wants you to draw the asymptote, and then you're going to click on the graph a function button, and it's just going to draw the graph for you. So it's actually quite a bit less work than you would expect from ALEKS. I am going to rewrite my function over here. My function is g of x equals 2e to the x plus 4 minus 2. And first job is to plot 2 points. For my first data point, I'm going to choose x equals -4. The reason that I'm choosing that as my first data point is because when x is equal to -4, that's going to make my exponent 0, and that makes it really easy to solve this function. G of x equals 2e to the -4 plus 4 minus 2. That is 2e to the 0 minus 2. Anything raised to the 0 is just 1, so this is 2 minus 2, which is 0. So when x equals 4, my y value, g of x, is 0. And we're going to plot that point, which is right over here. Now, you can plot it using ALEKS's little pencil, but it has this really awesome tool. This is the first problem that I've seen that uses this tool. If you click on that, it's going to open up a pop-up box. And that pop-up box has got, down in the bottom corner here, is going to give you the option to enter in x and y coordinates. For this, we've got x equals -4 and y equals 0, and then there's like a little button or somewhere over that says plot that point, and it is going to plot the point for you. This is a really powerful tool. You might not see why yet, but you're about to see why in a second. All right, so there's 1 point plotted. Now we've just got to pick a second point to plot. Let's just go to the next x value. So let's go to x equals -3, and let's calculate what y is when x is -3. My function g of x is 2e to the x plus 4 minus 2. And that is 2e to the 1 minus 2. Now, we could use our calculator to figure out exactly what that was numerically, but we don't have to because of this awesome little plot a point function on ALEKS. So what we know, when x is equal to -3, y is equal to 2e to the minus 2, and we can actually use this tool right here to plot that exact point. So open up that window and enter in your x value as -3, your y value as 2e minus 2. I think I've been saying 2e to the minus 2. That's not what I'm writing. 2e minus 2. 2e minus 2. Make sure you hit that plot the point button, and it is going to plot that data point for us, and that data point is like right around here. And so that is step number 1, plot the 2 points. We've got that done. The next thing that we have to do is draw the asymptote for this graph. So we have got to figure out, because it's an exponential function, we know it's going to have some sort of shape to it like this. We've got to figure out where that graph levels off, like, where exactly. I'm drawing really bad exponential functions, but we've got to figure out where it levels off, where the asymptote is. I'm going to erase this, get this out of the way. These are the tools that we'll use to put the asymptote in place, a horizontal asymptote versus a vertical asymptote. Okay, so from looking at the plots that we've pointed so far, as the x value increased, so when I went from x equals -4, when I went up to x equals -3, the y value was increasing. So I think that as x gets more and more negative, as x gets smaller and smaller, my y value should be decreasing, and that I think that it's going to just sort of level off. So let's kind of test that hypothesis. As x gets smaller, we get smaller and smaller numbers, what is going to happen to the term 2e to the x plus 4. So 2e to the x plus 4. As x gets smaller and smaller and smaller, this term, as x gets more and more negative is what I should be saying, not smaller. As x gets more negative, this 2e to the x plus 4 term is going to end up getting more and more negative. I'm just going to write very negative up here in the exponent, whatever it is. Let's try a couple of those out. What happens if we have e to the negative 10? And let's compare that to e to the negative 20. So we're just looking at a couple of e values where things are getting more and more negative. We can see we're getting numbers 4 to the minus 5, 2 to the minus 9. This just starts getting smaller and smaller and smaller. This term goes to 0. It's just working its way, slowly working its way to 0. It's just getting smaller and smaller and smaller. So as x gets more negative, our function turns into 2e to the x plus 4 minus 2. As x gets more negative, this portion becomes 0, and our y value, or g to the x, just goes to negative 2. That is our asymptote. Y, or g to the x, is negative 2. So we're going to use our asymptote button, and we are going to sketch that, have that sketched in place on the negative 2, y equals negative 2. Once you get that done, then you are going to click on the graph of function button, which is this button right here. You're just going to click on that, and ALEKS is going to put the graph in for you, which is super fantastic. I think the hardest part of this process is calculating the asymptote. And for me personally, when I'm trying to figure these out, I do exactly what I did in my calculator over here. I just start plugging in a couple of numbers and just seeing what it takes to get my g of x. To see what it takes to get this term with the x value in it. What does it take to get it to go to 0? And that is just sort of guessing and checking is the method that seems to work the best for me.